subsets. Definition: if every element of a set A is also an element of B, then A is called subset of B. So as you see, subset, so this somewhat imply smaller. If A is a subset of B, we write it as A contained in P. So this is the symbol to denote subset. And we can look at this in another way also. As A is a subset of B, we also say B is a superset of A. So the definition of superset is if B contains A, B is called superset. That is, B contains A. Now, how can we express if A is not a subset of B? A is not a subset. Then using the same, and we just strike this symbol. This means A is not a subset of B. Here we make a remark that we already discussed the definition of equal sets. So here, using subset, how can we prove sets are equal? They are equal if and only if A contained in B and B contained in A. Then two sets are said to be equal. So we will take some example. Let B is 1, 2, 3, 4, 5 and A is 1, 2, 3. So clearly, when we apply this definition here, every element of A is also a element of B. So A is called subset of B and B is called superset of A. Why? Because B contains A. Now we will discuss some types of subsets. There are two types: proper subset and improper subset. So first we discuss proper subset. A non-empty set is said to be proper subset of B if A contained in B and A is not equal to B, then we say A is a proper subset of B. What this means? Like here in this example, A is a proper subset of B. That means there exists some element in B which is not in A. So how can we express this? That there exists X belongs to B such that X does not belong to A. So in this case, A is called proper subset of B. Now improper subsets are trivial subsets. Trivial subsets. What are those? Phi and set itself. So every set has two trivial subsets. One is empty set, another is set itself, and these two sets are called improper subsets. So again we make a remark here that if a set A has m elements, the number of subsets of A is 2 power m. The number of subsets of A is denoted by 2 power m. So we will discuss this with a small example. Let A is equal to 1, 2, 3. So what is the value of m here? M is equal to 3. So as per this result, number of subsets is equal to 2 power 3, that is 8. So can we write those 8 subsets? Yes, we can easily write. So they are 2 trivial subsets, that is phi and the whole set 1, 2, 3. What else? 1 only, 2, 3, now 1, 2, 1, 3 and 2, 3. So this is 1, 2, 3, 4, 5, 6, 7, 8. So these are the 8 subsets of this set A, including improper and proper subsets. So these 6 are called proper subsets and these 2 are called improper. So we will again repeat the definition here. Proper means there exists at least one element which is not a part of this. As you see, this is contained in this, but they are not equal. So this applies for all these. And also there exists at least one element, like here 2 is there but 2 doesn't belong to this. Here 1 and 3 belong to this. Here 1 and 2 does not belong to this. So in this way these are proper and these 2 are improper. So next we will move forward towards interval as subset of R. R is set of real numbers. So there are 3 types: open interval, second is closed, and third is semi-open or semi-closed. So we start with open interval first. So we start with two real numbers a and b belonging to R such that a is less than b. Then we just write the syntax first. In x belongs to R with, so you see, set of all real numbers which lie between a and b with strict inequality. This is called open interval and is denoted by round brackets a comma b. Here endpoints are not included in this set. Only the members strictly greater than a and strictly less than b are the part of this set. If we try to express this on a real line, this is a real line, minus infinity to infinity. Let this is a and this is b. So here, so open interval means the element which starts from here to here, these elements. So endpoints are not included. Second is closed interval. So again we start with two elements, real numbers, such that a less than b. Now here closed interval is denoted by square bracket. X belongs to R, so all those elements less than equal to x and this, so which are greater than equal to a, less than equal to b, including the endpoints. So this is denoted by square bracket and this is called closed interval of this set. So on real line, again here endpoints are also included. Number 3, semi-open or semi-closed interval. So we start with same, AB belongs to R such that A less than B. So semi-open means this, means to say X belongs to R with X greater than equal to A but strictly less than B. We can easily check this. This left hand side is included but right side is not included, strictly less than B. Another type is this. How can we express this as X belongs to R with A and less than equal to B. So these types of sets are called semi-open or semi-closed sets. Some examples of infinite intervals. For example, this. Here, this is the interval of all real numbers with X greater than equal to A. So from A to infinity. So how can we express this on real line? This is minus infinity to infinity, and here somewhere let it is A. So all those points from A to infinity including A. So this is an infinite interval. Another way is a to infinity. So the only difference is here endpoint is not included. X is strictly greater than a. Now also we can have minus infinity to a. That is x belongs to R with x less than equal to a. Similarly, minus infinity to a, that is x belongs to R, x strictly less than a. Another set, minus infinity to infinity, that is all real numbers, set of all real numbers. Now what about positive real numbers? This, all x greater than equal to 0, that is R positive. Now next we will have an important definition, power set. So power set is a family of all subsets of a given set A is called power set of A and is denoted by PA. So syntax is, what is PA then? All those sets which are subset of A. This is set builder form definition. All those sets which are subset of A. And we already seen previously how many subsets are there for a set. If we know the number of elements, if it contains m elements, the number of subsets are 2 power m. So by that, what is order of power set? That is 2 power number of elements in A. If it is m, then this. If Na is m. Now let us take an example. Let A is equal to 1, 2, 3. What is power set of A then? Power set of A is empty set 1, 2, 3, 1, 2, 1, 3, 2, 3, 1, 2, 3. We will count them 1, 2, 3, 4, 5, 6, 7, 8. So all the 8 subsets are written here. So this is called power set of A. Again we will apply the definition, family of all subsets of given set is called power set. And the number of elements is 2 power m. Another set is universal set. So definition, if all the sets under consideration are subsets of a set U, then set U is called universal set. So we will just try to understand this universal set. So here As you see, if these are the sets under consideration, what is universal set for these? This 1, 2, 3. So this is a universal set for all these subsets. And another example is, so while dealing with intervals, what is universal set? R, set of real numbers, because every interval is a subset of real numbers. So R is a universal set. After discussing the definition of subsets, now we discuss some numericals based on subsets. Now first question is, for a set capital A is equal to 1, 2, here this is a set 3, 4 and 5. Which of the following statements are incorrect and why? Here, first of all, make it clear that all these are members of capital A. तो capital A ਦੇ member किस तरह ਦੇ है? They are the elements as well as set. So we try first question. You see 3, 4 belongs to A. So is it an element of this set? Yes, of course. So this is a correct statement. So this is not incorrect. This is correct. Next question. 1 belongs to A. Is 1 belongs to A? Yes. So this is again, this is correct. This is also correct. Third question. 1 is subset of A. Now make it clear that the symbol 1 belongs to A and 1 contained in A. They are different. For an element to be contained in A, that has to be a subset. So if it is of like this, then it is contained in A. So this is incorrect. Number 4, 1, 2, 3 contained in A belongs to A. Is it belongs to A? Again, this is incorrect. One, two, three contained in A. This is also incorrect. Phi belongs to A. Whether empty set belongs to this set? No. So this is also incorrect. Empty set is a subset of A. Yes, this is correct. Now second question. Let A, B and C be 3 sets. If A belongs to B and B is contained in C, is it true that A is contained in C? If not, give an example. So again, try to apply the definition of subset. The solution for this, given A belongs to B and B is contained in C. Now here we can easily guess that this implies that A is also belongs to C. So that means A contained in C is incorrect. Now for example, let A is equal to 1, 2, B is equal to 3 1 2, C is equal to 3 4 1 2. Now as you see, as per given, from these two we have that A belongs to B. You see, this is an element of B. Now next, whole of this B is contained in C. These two imply, and from here you will easily see that 1 2 is an element of C. So this imply A belongs to C. 1 2 is an element of C. Why not? This is subset. For subset, it has to be written like this. So here it is written A contained in C. So this is not, and this is the example. Next question. Let two finite sets have M and N elements if total number of subsets of first set is 56 more than the total number of subsets of second set. Find M and N. So we are given order of two sets. Let two sets are A and B, and order of A is M and order of B is N. And we all know the number of subsets. How many number of subsets of A? Number of subsets is equal to 2 power M, and number of subsets of B, 2 power N. We are given that subset of first set is 56 more than the total number of subsets of second set. That means this imply 2 power M is equal to 56 plus 2 power N. Now we have to calculate value of M and N. So we use here hit and trial method. By that method, you see on the right hand side we have 56. So we chose that value of M which make this power more than 56. You see, if we raise this power 4, then this is 16, 5, 32, and when we raise this power 6, if we choose M is equal to 6, 2 power M becomes 64. We choose M is equal to 6, that makes 2 power M is equal to 64. So which is more than 56. How much more than 56? 8 more than 56. So how can we have 2 power N is equal to 8? By choosing N is equal to 3. So this imply 2 power 6 is equal to 56 plus 2 power 3. So from this we have M is equal to 6 and N is equal to 3. Answer. Next question. Write the following intervals in set builder form. You know, set builder form means we have to write the property of the elements satisfied by them. So the set builder form of this interval is all those real numbers belongs to this having strict inequality this, because this is an open interval, so endpoints are not included. Now second set, this is semi-open or semi-closed. So again here all those real numbers belong to that set with 12 less than equal to x, strictly less than 27. Now next question, find the power set of this, where phi is an empty set. So you see phi is an empty set. So what is power set of empty set? So how many elements are there in empty set? 0. So p of phi, you see p of phi is, how many elements are there in this? 2 power 0, that is 1. What is that? Only phi. Then now we have to find p of phi. That means p of phi. So what is that? That may be empty set and set with phi. Next, third time again, p of phi. Which is p of phi of this. So how much is that? This is phi, curly bracket of phi. Now subset phi and phi of this. So this will be the answer.